Today we're going to be graphing polynomial functions. So a polynomial function, when it's graphed, has turning points. So it's not going to be a linear graph, it's going to be straight. It's going to have turning points. And we're going to be learning about the turning points, the maximum and minimum. So our maximum minimums are the lowest, or minimums are the lowest points of our terms, and the maximums are the highest point of the term, which we're going to talk more about in a minute. And then we're going to be talking about the end behavior. So like, how does the graph keep going on towards infinity? And then we'll be graphing them. Okay. So turning points. Your turning point is determined with a polynomial that has an n number of real zeros. It is graphed, has exactly n minus 1 turning points, and the n stands for the degree. So let's write that down here, that the n is the degree. So if something is raised to the third power, and that is your highest exponent, then it's going to have a degree of 3. And then we take 3 and we minus 1 from it, and that tells me how many turning points I'm going to have. So 2. Okay, if it has, it's always 1 less than the degree. Okay? So for example, on that previous slide, this has 3 turning points, so my degree would have to be 4. That has 2 turning points, so my degree would have to be 3. It's always 1, the turning point is 1 less than the degree. Okay? That's what this stands for, exactly the degree minus 1 turning points. The relative maximum and minimum. The relative maximum is also known as the local maximum, is the y-coordinate of a turning point higher than all the nearby points. So for example, this would be my maximum because it's the turning point. Technically my graph keeps going on forever in both directions up, but the highest turning point is your maximum. Your relative minimum or local minimum is the y-coordinate of the turning point that is lower than all nearby points. So it's the lowest turning point. So for example, here and here on this graph and here on this graph. Okay, and it's the y value because that's what is determined up and down as y. Okay? So in behavior, this is what happens at the end of the graph as the x values get to infinity large or positive infinity or towards negative infinity. Okay? And so as x approaches positive infinity, what happens to y? And as x approaches negative infinity, what happens to y, or f of x? The end behavior is going to be determined by 2 things: the sign of the leading coefficient and the polynomial's degree. Does anybody know what it means by leading coefficient? Yes. Coefficients are numbers in front of variables. And what do you think the leading would mean? Yes, Aiden? The first one. Okay? So if the first sign is positive, we're going to look at positive. If the first sign is negative, we're going to look at negative. Okay? And then the degree. So even and odd degree. That's all that we need to know for end behavior. So if our leading coefficient is positive, and we have an even degree, like 2, 4, 6, 8, then it's going to, as x approaches positive infinity, our f of x, or y, also approaches positive infinity. As my x approaches negative infinity, my f of x, or y, also approaches positive infinity, like this, like that first one on the first slide. If our leading coefficient is negative and it's even degree, as x approaches positive infinity, our y, or f of x, can go negative infinity, so down. And same thing with our negative infinity, it's also going to go down. So when it's even, they're kind of like in a race with each other. They go the same direction. Okay? So I'm going to write that up on our top of our slide. You might want to write it off to the side. So even goes same way. Okay, and then odd degree. So if it's positive leading coefficient and it's a odd degree, so positive infinity, it's going to also go positive. Okay, as it goes to negative infinity, it's going to go to negative infinity. So it's going to be kind of like a positive slope. Okay, but there's going to be turning points in the middle. And then if the leading coefficient is negative and the degree is odd, then as it goes to positive infinity, it's going to go down. And as it goes to negative infinity, it's going to go up. It's going to be like a negative slope. Okay? And if you look at, so if for odds degree, they go in opposite directions. So odd, opposite. Remember, they're having them being odd. So they're going to go opposite. And then your extra notes has an examples, okay, of pictures. So if you look at the extra notes, even, positive, both up. And what it says in behavior, this is literally what you're going to be writing when asked for the end behavior. Okay? Even, negative, both down. There could be turns in the middle though. Odd, positive, opposite directions, kind of like a positive slope, but there might be some turns in the middle. Okay? And then odd, negative, kind of like a negative slope. Okay? But there might be turns in the middle here. So on your test, or at times, they're going to ask you to describe the end behavior. So what we're going to be writing down is exactly what it says by end behavior, that middle section of x approaches positive infinity or x approaches negative infinity. Okay? And then like the little arrow. So first off, we need to determine the sign of the leading coefficient. What is my sign of my leading coefficient? Is it positive or negative? Negative. Okay, and then the degree. What is my degree? Is it even or odd? 3 is my degree, so that's going to be 3 is odd. Okay, so 3 is odd. Okay, so we're going to look at our graph or our extra notes, and we're going to look at negative and odd. So as x approaches negative infinity, as f of x approaches what? When it's negative and odd, what does it approach? Plus infinity, so positive infinity. So this is literally what we're going to be writing when it asks for you to describe the behavior. You're going to be writing this part here. And then as x approaches positive infinity, as f of x or y approaches what? Negative infinity. Because it's odd, they're opposite directions. And it's negative, so it's going to be a negative slope, something like this. And this will have 2 turning points because the degree is 3. Okay, sign of my leading coefficient here. Positive, because there's no value up front. Okay, and my degrees, even or odd? Because it's 6. So now looking at our extra notes, as x approaches negative infinity, as f of x or y approaches what? Positive infinity. As f approaches positive infinity, as f of x, this is even, so it's going to go in the same direction, so it's also going to be positive infinity. You're going to be able to use those extra notes on your test, okay? So I'm not expecting you right now to memorize this. However, later on, you will. Just remember, even, same direction, odd, opposite directions. If it's positive, up, negative, down. Negative slope, positive slope. Okay. Okay, graphing polynomials. You need to find the zeros of the function. How we do that, we set each factor equal to 0. And solve. Once we do that, we're going to create an XY table and substitute 5 to 7 values in for X and to find Y. So the X values that you should be using is 1 less than your lowest 0 and 1 higher than your highest 0 and then the numbers in between. And you'll see what I mean by that in just a second. And then once we do that, we're going to plot all those points. We're going to use the information that we know about end behavior and turning points to complete the rest of the graph. Okay? On your guys' test, the question is going to be multiple choice, so you can probably figure this out by figuring out the zeros and the end behavior and turning points alone. You don't need to graph it, but later on you might have to, so that's what we're going to do. Okay, so there are 2 x's here. So if there's 2 x's, that means this is going to be x squared if we were to FOIL this. So that means it would have 1 turning point. It's 1 less than the degree. It would also be even and positive, so they're both going to be going up. Okay, so we know even, positive, so up, up. Okay, up, up. Okay, so now that I know my information, I know it's going to have 1 turn, it's going to be going up and up. Let's set our factors equal to 0. So I'm going to take x plus 1 instead of equal to 0, and x minus 3 instead of equal to 0, and solve. So that's going to be x equals -1 and x equals 3. So that means when y is 0, my x value is going to be -1. When y is also 0, my x value is going to be +3. So those are my zeros, the x-intercepts. Okay? I need to now pick x values that are 1 smaller than my lowest x-intercept and 1 larger than my x-intercepts. So I'm going to create an xy table. And 1 smaller than -1 will be -2. I do not need to do -1 because it's going to be 0. We already found that out. So then I'll do 0, 1, 2. I already have 3. I need to do 1 larger, so 4. Now I'm going to take my equation, y equals x plus 1 and x minus 3. And I'm going to substitute each one of my x values in and find y. Okay? So I'm going to have 2 plus 1 times 2 minus 3, which will be 3 times -1. Or I'm sorry, 3 times -5. It's going to be -2. I'm sorry, I did that completely wrong. -2, not +2. So that's going to be -1 times -5, which will be +5. Now we're going to substitute in 0. So 0 plus 1 and 0 minus 3. So that's going to be 1 times -3, which is going to be -3. Substitute in 1. So that's going to be 1 plus 1 and 1 minus 3, which will be 2 times -2, which is -4. Substitute in 2, so 2 plus 1 and 2 minus 3. So that's going to be 3 times -1, which is -3. Substitute in 4. 4 plus 1 and 4 minus 3. So that's going to be 5 times 1, which is 5. So these are going to be my ordered pairs I'm going to plot. Okay? So at -2, my y value is 5. At 0, my y value is -3. At 1, my y value is -4. At 2, my y value is -3. And at 4, my y value is 5. So we know it's up, up, and it has one turning point. And then we just complete our graph based on kind of what we know. You can always take a picture of this. Look and erase. Okay, so I have 3 x's here. 1, 2, 3. So 3 x's means that this is going to be x to the 3rd. So that's going to be how many turning points? 2. 1 less than the degree. So 2 turning points. All right, and so it's odd and negative because of the number out front. So odd negative is kind of like a negative flip, so it's going to be pointing up and then down. Okay, so it's as it goes to positive things can go down, as it goes to negative things can going up. So now I'm going to set each one of my factors, all 3 of them, equal to 0. So negative x equals 0, x minus 2 equals 0, and x plus 4 equals 0. So then I'm going to solve for my x's. So that's going to be divide by -1. So my x is going to equal 0. Add 2. X is going to equal 2. Subtract 4. X is going to equal -4. So when I'm making my xy table, I need to have a value that's 1 less than -4 and 1 more than +2, and then all the values in between. So I'm going to do -5. I do not need to do -4 because I already have -4. -3, -2, -1, 1, and 3. And then we have our equation, which is y equals -x, x minus 2, and x plus 4. So I'm going to substitute each one of my x values in and solve for y. So negative times -5, and -5 minus 2, and -5 plus 4, which is going to equal 5 times -7 times -1, which is -35. Okay? I'm just going to give you guys the rest of the y values because you guys can substitute these values in and solve. So we're going to get -15 for -3. -2 is going to be -16. -1 is going to be -9. And 1 is going to be 5. And +3 is going to be -21. So now I'm going to plot these points. So at -5, I'm going to be at +35. I should have +35. So it's a negative multiplication. I'm sorry. So it's going to be +35. That's going to be up here. Okay, we know our graph's going to be pointing up and then down, so that's going to be my up value. Then at -3, we're going to be at -15. -2, I'm at -16. -1, I'm at -9, so it goes up. And then at 0, I'm at 0. And then at 1, I'm going to be at positive 5. And then at 2, I'm at 0. And 3, I am at negative 21. So this is going to be one of my turning points. This is my other turning point. And remember, it's going towards positive infinity. As your x goes negative, and towards negative infinity as your x goes positive.